Hello, everyone. Thank you for joining us for the WWF Insiders Series virtual event. My name is Ariana Bowman, and I work with WWF Legacy Circle members on the East Coast. In a couple minutes, I'll introduce Dr. Robin Naidoo, WWF Senior Conservation Scientist and Lead Wildlife Scientist, who will talk to us about his work in the Kavango-Zambezi Transfrontier Conservation Area, or simply put, KAZA. But before I turn things over to Robin, I want to point out a few things about today's virtual event. We will have time for questions following the presentation. If you have a question you would like to ask Robin, please use the Google form below the video player in your web browser. Our team behind the scenes will be monitoring your submissions throughout the presentation. And we will try to answer as many questions during the Q&A portion of today's event as we can. If you would like to maximize the size of the video screen, float your mouse over the video player and click on the expand icon at the far right of the toolbar on the bottom. To exit out of the full screen mode, which you may want to do to submit a question, you can minimize your video by pressing the escape button on your keyboard. And a final note, we are recording today's webinar so we can share it on the WWF website. Now for today's topic. The Kavango-Zambezi Transfrontier Conservation Area, or KAZA, was established in August 2011 and is the world's largest transboundary conservation area. KAZA covers an area roughly the size of France and spans territory across 5 southern African countries, including Angola, Botswana, Namibia, Zambia, and Zimbabwe. The region's woodlands, wetlands, and grasslands provide habitat for 225,000 elephants, the world's largest population, 25% of Africa's wild dogs, almost 20% of the continent's lions, and approximately 15% of the world's cheetahs. This cross-border collaboration addresses the urgent threats of poaching and climate change while allowing communities and governments to manage their resources better, assist in the development of the area as a tourist destination, and help create corridors that give wildlife the freedom to roam. Today, we have the pleasure of hearing from Dr. Robin Naidoo in his role as lead wildlife scientist. Robin investigates the ecological and economic issues that impact wildlife conservation. His work, from mapping ecosystem services to monitoring animal migrations, places nature at the center of sustainable development and supports a future where species and people coexist. Robin, we are so looking forward to hearing from you.
Thanks very much, Ariana, for the kind introduction. And hi, everyone. Really appreciate you joining us to hear a little bit about our work, conservation across borders, and in particular, as mentioned, in the Kavango-Zambezi Transfrontier Conservation Area, or KAZA. So, we heard a little bit about some of the facts regarding KAZA. It's an absolutely massive area, almost 110 million acres. About the size of France, spans 5 different countries. Really one of the crown jewels of conservation in Africa, if not the world. Tremendous diversity of species, including some of the really iconic African species of wildlife that we all know and care about. It's also home to a lot of people, several million people. And so one of the fundamental questions in this conservation landscape, as in others, is how do we achieve conservation results while also making sure that the people in the region benefit from wildlife and are able to improve their livelihoods? And so that's really one of the key objectives of KAZA, is to use wildlife-based tourism to for the purposes of sustainable development and to improve people's livelihoods in this area. And so one of the fundamental planks of this then is really trying to understand what it is that wildlife need to persist in this area, particularly with regards to their space needs, to their movement behavior, to their migratory patterns. And so we've spent now the better part of 15 years trying to understand exactly that. And so what I'm going to talk to you about today is a long-term program of applied research where we've really dug into this question. And I've been involved with this since 2007. And this is a really fun and thrilling part of my job, where essentially what we do is deploy GPS satellite tracking collars on a variety of different large wildlife species The animals are typically darted from a helicopter, so they're sedated and immobilized. We attach a satellite tracking collar to them, and then we administer a drug. All of this is done with the help of a wildlife vet. That drug reverses the sedatives, and the animals go off and rejoin their herds and go about their day. And so this sort of gives you, this picture gives you a bit of an idea of what it's like to be in the field with these large species of wildlife, and really up close and personal. So this is a younger version of me about 15 years ago, putting a satellite tracking collar on an African buffalo. And we've done this with a variety of different species, including wildebeest, like we see here. Also, plains zebra. And some of you perhaps have heard that in the course of doing this research, we inadvertently discovered what at the time was Africa's longest wildlife migration of zebra that leave a communal conservancy in Namibia and travel huge distances south into Botswana and Pan National Park. So really interesting result that we actually didn't know was going to come about when we started this research. We also collaring various types of predators, such as this lion, wild dogs, cheetah, leopards. We've even put a few transmitters on crocodiles, and this is pretty exhilarating, even more so than the previous helicopter-based work. In this case, the animals aren't actually immobilized with any kind of drug. They're simply unable to move because we're sitting on the animal. But you can imagine that in order to let the animal go, eventually all three of us here just had to run off and hope that the crocodile was more interested in getting back into the water than any of us. So, really exhilarating work, and it's been an absolute thrill to be a part of this research over the last decade plus. So the fundamental goal of all of this is really to understand movement patterns of these different species. And what I want to talk to you particularly today about is the movement of one species of real particular importance to us in KAZA, and that's the African elephant. So as Ariana, I think mentioned earlier, KAZA has the largest population of African elephants anywhere on the continent. It's a real stronghold for them. We want to obviously make sure that continues. So, elephants are a major species of ecological importance. They're of economic importance as well because of the way that they draw tourists in. They're also a species that can sometimes come into conflict with people just due to their huge space requirements and the potential for damage to fields and people's livelihoods and so forth. So it's really important for us to understand what it is that elephants need in this landscape in order to thrive. And so if we go back to a map of the KAZA landscape, so this is a sort of slightly different view. That the outline of KAZA is in black, and the different colors represent different types of protected areas in the landscape, whether that's national parks, game reserves, communal conservancies, and so forth. And, from a sort of quick glance at this map, it looks like, the colored areas are pretty continuous, pretty connected. There appears to be, a nice mosaic of these different types of parks and so on that are relatively well connected to each other. But the reality on the ground is a little different. There are barriers to movement in this landscape, and none are more important, we think, than fences. And that's what those red lines indicate on the map. So these are fences that have been erected over the last 50 years or so at various times. Their purpose is to keep wildlife and livestock separated for the purposes of disease control. And, by and large, they've been very effective at that. They've had, real negative impacts on wildlife in this region over the course of the last decade. So it's important to really understand what impact they're having currently in their current locations, because they do present a possible barrier to this vision of an interconnected transfrontier conservation landscape. And so we really wanted to hone in on what impact these fences might be having on the elephants in the region. So this is an example of what one of these fences look like. And in particular, I'm going to talk about fences that are located along the border of Namibia and Botswana, which are two of the KAZA countries. So this fence here gives you a sense of what they look like on the ground. Actually, along the border, they're often double fences. So you'll have a fence, a bit of a space, and another fence. But they're really quite variable in different locations. And some of them aren't in particularly good condition at the moment. So these fences are actually quite costly to maintain. So you can see that some of these fences fence posts rather have fallen down here. There can be actual gaps in the fence. Sections can be completely destroyed. Many of these fences were electrified at the outset. That electrification no longer works in many places. And so, the effect of these fences, in one sense, is obvious. They're a physical barrier, at least to some of the wildlife species that roam the landscape. But that condition, that barrier effect, we have reason to believe really varies. And we know this from our own research and experience on the ground in this area. So for example, here is a picture of an elephant taken some years ago now by a colleague of mine that has managed to get itself in between these two fences that run along the border between Namibia and Botswana. So clearly there is potential for at least some of these animals to get in between and to cross these fences. On the other hand, we also have evidence that, as one might expect, these fences do pose a barrier to various species of wildlife. And so I'm going to show you here an animation of 6 elephants that we collared a number of years ago. The key point to look at here is that sort of horizontal heavy black line running left to right on your screen. That's one of the parts of the border between Namibia and Botswana, and it's fenced. The other thing to notice is just to the right of that heavy black line, there's a bit of a gap right now where those black and green sort of animated elephants are. There is no fence right there along the border between Namibia and Botswana. So let's see what happens when we roll this forward. This is basically just going to show these elephants moving around. And you'll notice a couple of things. First, you'll notice along that heavy black border between Namibia and Botswana, again, that's the fence. You can see that these animals, they're moving alongside the fence. They might be right up close to the fence, but they don't actually cross the fence. And again, these are female collared elephants. If you look at that gap right now where the green animal is, you can see that on the other hand, where there's no fence along the border, we do see animals moving back and forth between Namibia and Botswana. So there is this transfrontier connectivity, which again is the hope for a place like KAZA. But we also see that connectivity is disrupted in places where there is a fence, in particular that section there between the Namibia and Botswana border. So, on the one hand, we've got evidence from the male elephant that we saw, photographic evidence that these animals, at least males, will cross fences. However, none of these female elephants cross the fence for this sample period that I just showed you. So we wanted to, again, to dig into more detail on this question. And so what we did is we put together GPS data from 105 elephants, so 41 males and 64 females. And this was a collaborative effort between WWF, between an organization that works in Botswana, EcoExist, and between the respective governments of those countries. And together that equals about 1.5 million GPS points. So the largest set of data that's ever been assembled to tackle this question on what are the impacts of fences on elephants. This work doesn't cover the entirety of KAZA, but it does cover a large part of the central part of KAZA. So if we go back to our map here of KAZA, the work that I'm showing you is going to take place in this region here with this rectangle. So what I'm doing now is showing you that rectangle, zooming into that area, stripping out some of the background layers for clarity. But again, what we're seeing here is fences, this time in the dark black color. Those heavy lines are fences. The animation that I showed you earlier happened basically in the middle part of the screen in that long, narrow rectangular section. So when we assemble this data and plot it out on a map, what do we see? So focusing first on male elephants. So those animals that were collared in Namibia are shown in red, and those that were collared in Botswana are shown in gray. And what we can see is that these two lines, sets of lines, do intersect. So there is exchange of male elephants between Botswana and Namibia. You can see that they cross these heavy black lines, these fences, in a number of different places. Although we do see evidence, if you look closely, that there are some parts of the fence that do seem to nevertheless be barriers to elephant movement. And we can also see that the part of the Namibia-Botswana border that's not fenced, it's sort of directly in the screen there where some of the red lines are, we can see movement across the borders there. So, on the one hand, just like that animation that we saw earlier, we do see cross-border connectivity where there aren't fences. And we do see connectivity as well where there are fences, although perhaps not as much as there would have been without those fences there. So this again is for male elephants. If we turn to female elephants, the situation is radically different. And I think it's just very clear from this figure to see that where there are fences along the Namibia-Botswana border, there's simply no exchange of animals collared in one country moving into the other country. So all of the red animals, elephants, female elephants collared in Namibia, stayed in Namibia unless they came into contact with a part of the border that wasn't fenced. And again, then we do see good exchange between the two countries for female elephants, but it's very clear that fences that run along the border between the two countries and also fences that are internal to Botswana, really do provide almost, entirely complete separation between these elephants. Another way to look at this result is to plot it out on a graph. So on the vertical or y-axis, we've got the percentage of times that a fence is crossed. And then on the x or horizontal axis, we've got the distance from the fence that our last GPS point was recorded. So essentially, we're looking at if an elephant comes into contact with a fence at a certain distance, what's the likelihood that it goes on to cross that fence? And for female elephants, again, this is very clear because we recorded no instances of female elephants crossing a border fence when they came into contact with that fence at whatever distance. So that's just 0 for all female elephants. For male elephants, the curve looks like this. So for example, when a male elephant came within 50 meters of a fence, it crossed that fence subsequently between 1/4 and 1/3 of the time. And that curve then declines the further out that contact was from a fence, the less likely it was to cross that fence, which is what we would expect. And the scale on the x-axis is from 0 to 1,000 meters or 1 kilometer. So that's what happens when these animals come into contact with border areas that are fenced. When they come into contact with areas that aren't fenced, the green curve is showing the results. And so what we see that if an elephant comes into contact with a part of the Namibia-Botswana border that is unfenced, if they come into contact with that fence 50 meters away, they go on to cross the fence almost half the time. And then you see the curve decline as distances get larger. But essentially what we see is that there is an impact of this fence. So even though males do cross fences, they essentially cross it less than we would expect. And that comparison is to the unfenced border up to a distance of about 500 meters. So we can essentially say that these fences are having a negative effect on elephant movement, on elephants crossing into the other country up until about 500 meters. So this is really the most comprehensive analysis we think that has been done to date, looking at the specific impacts of barriers like fences to animal movement and to connectivity in the KAZA region. So, where do we go with this? I think what we'd like to do is, as I mentioned earlier, these fences really they can be in quite different conditions depending on where you are in the border. And so we'd like to have a closer look at different fence sections that we know are either, in good condition or in poor condition, and see if we do see more crossings of elephants in those sections. We also need a bit more data from this unfenced area of the Namibia-Botswana border. The data that we had there was biased towards female elephants. We'd like to know a bit more about what male elephants are doing in that area so that we have an appropriate comparison to make with the fenced borders. All of this information is really being done to provide, all of this research rather is being done to provide scientific information to the governments of the region on the impacts of fences, on the vision of KAZA. So KAZA is a government-led initiative, and it's our job as WWF and the other organizations that are working in this region to provide them with the best available information on things like fencing so that they can make decisions. But there is appetite right now to think about these fences and to evaluate, whether the impacts that we're seeing in terms of wildlife movement, do they justify a reconsideration of how fences are aligned, or whether fences should in fact be decommissioned in some instances. There's increasing ways in which livestock and wildlife disease can be managed. These fences are extremely costly to maintain, and so there's an incentive there to not have to pay for their maintenance if at all possible. And so all of this work that we're doing on this topic, I think, can really help us understand better the impacts of potential barriers in KAZA, and to do what we can to mitigate those barriers so that this vision of a transfrontier connected landscape that works for both wildlife and people can be made a reality. So thanks very much for listening, and I think I will turn it back over to Ariana right now.
Thank you for sharing this important work with all of us, Robin. We'll now turn to the questions submitted via the Google form and do our best to get to as many as we can. Okay, first question. This first question is from Stephen. Why is South Africa not part of this consortium?
So the Transfrontier conservation location is in such an area that South Africa doesn't border it. So it's not a part of this particular Transfrontier conservation area, but South Africa does have a number of other Transfrontier conservation areas, including with Botswana and Namibia in the south of those countries, and also a really famous one that involves Kruger National Park in South Africa, and the corresponding area on the other side of the border, which is in Mozambique. So South Africa isn't a part of KAZA just because of where it's located, but it certainly is involved in other transfrontier conservation efforts.
Thank you for providing more information on that. All right. And next question is from Alyssa. Do the collars have a breakaway designed to ensure that they don't accidentally ensnare the animal and also allow for growth?
Yeah, that's a really good question. And collar fitting is important because it is critical, obviously, to make sure that the collars don't have impact on the animals. So these collars in particular don't have breakaways simply because they can be quite tricky to design properly, and they can inadvertently fall off if they're not properly designed. These are really massive animals that are quite hard on the collars. Some of them do manage to break them off anyway, even though there is no specific breakaway. What we always do, though, is remove the collars after 2 to 3 years. So that's about the lifespan of the collar. And once that time is coming up, we then charter another helicopter and do our best to remove those collars. The collars are also designed such that they're only a small fraction of the animal's weight. And so we work with a manufacturer, an African manufacturer based in South Africa, who has a really good understanding of the behavior and the natural history of these species, so that the collars can be made in such a way that they have as little impact on the animals as possible.
Thank you for that. All right. And this next question is from David. Can't male elephants just knock down the fences?
Yes, they definitely can, and in fact, so can female elephants. So both of them are more than capable physically of crossing these barriers, especially because some of these fences, as I mentioned, are in such a condition that relative to an elephant, they're quite flimsy. So, one of the things that does arise from this research is, why is it that only male elephants are observed crossing these borders, these barriers, when female elephants are physically capable of crossing them? And what we think is going on in that instance is that females are almost always in breeding herds where there's younger elephants, some of them quite young, and so those elephants may have difficulty crossing the fences, the younger ones. And so that may be the reason that the female elephants don't cross. As to why male elephants don't cross every time when they're capable of it, it's not entirely clear yet at this point. It may be that these barriers, even though not totally impermeable, might form a natural barrier to the elephant's home range. There's been suggestions that elephants remember the fact that even though these fences are not now typically electrified because they've just become dilapidated, they may remember when they were erected, or their parents may have shown fear of these fences when they were first erected in terms of the electric shock that they delivered, and so they just don't do it now because it's no longer a habit of theirs to cross. But I think these are still things that we really need to investigate, and that will definitely give us a better handle on those fence impacts once we understand those factors a little better.
Sure, absolutely. They're so intelligent. It's one of the reasons they're my favorite animal. The next question is from Grace. What alternatives are there to fences?
Yeah, I think the situation has really changed in terms of the management of diseases and livestock. So we've become a lot more sophisticated in how those are managed. And I'm not a sort of a livestock disease expert, but my understanding is that a lot of the concerns about disease transmission and diseases making their way into the meat, say, of cattle, which are then exported. There's more sophisticated, high-tech ways to handle that now on the processing side in terms of disease surveillance, in terms of the hygiene in meat processing plants, and so forth. And so I think, as well as better surveillance of wildlife populations and livestock on the ground in terms of whether they are or aren't infected with diseases that may be an issue. So I think there's more sophisticated ways now to handle this rather than using a fence, because a fence is really a pretty blunt tool that, yes, it can be effective at separating wildlife and livestock, but the side effects of having those fences out there are such that they can really harm conservation objectives, as well as being extremely costly. So I think this is an area of real active development, and it's our hope that this blunt tool of fences that have been sort of used over the last number of decades are now becoming such that we can use other tools to manage the potential for disease entering into livestock from wildlife.
Thank you. And yeah, certainly, um, I think this model could be used with a lot of our conservation work, and your research has really shown that. So, okay, next question. Um, do Bushmen play a role in this KAZA agreement?
The agreement is between the five governments of the region. So the agreement are between the governments of Angola, Botswana, Namibia, Zambia, and Zimbabwe. But here as elsewhere, it's absolutely fundamental that local communities who live in these areas are key parts of the decision making. That they see benefits from conservation interventions like KAZA, and that they really feel that like they have a role to play in conservation of natural resources, particularly with regards to improving their livelihoods. And I think Namibia, one of the five KAZA countries, has really been a model for the world to follow in terms of how to make sure that local communities are really benefiting from wildlife conservation. So there's what's called Namibia's natural resource management program, which has been instrumental in devolving user rights to local resources back to back to local communities, which those rights have previously been the property of the state. And our results in Namibia, this is a program that WWF has supported for many, many years, and it has really shown extraordinary results. And we've got some of those studies and that information on our website. But so it does show that if we can integrate local community concerns and ability to manage natural resources in conservation interventions, the outcomes for both people and nature are really good. So I think it's a great question, and the degree to which that's happening, I think, varies across the 5 different countries. But certainly because Namibia is one of those countries in KAZA, it really provides a great model that can be adapted in the other countries.
Absolutely, that's so important. Okay, and next question from Christina. What is the next step or study that will be undertaken based on the information you received from this incredible study?
Yeah, that's a great question. And so I think a couple of different answers. One is trying to, as some of the earlier questions raised, dig into a bit more of the mechanisms as to why males cross the fence sometimes in some locations, but not other times at other locations, trying to understand whether that's a function of fence condition, or is it a function of the behavior of the individual elephants themselves, or a function of something else, is something we don't understand at this point, and so that we need to understand better. But I think even though elephants are an extremely important species, they're only one species on the landscape. And so I think extending this study to look at a whole host of different species for which we do have the GPS data, much as we do for elephants, would really start to give us a more holistic understanding of the effect of fences on all of the different wildlife species that occur in KAZA and that we've been tracking over the last 15 years or so.
Thank you. Thank you for that. Okay, and it looks like this might be our last question from Jeff. Have you studied the impact on the predators of the region and their natural prey, or studied movement of the cattle?
Yeah, good question. We have not studied movement of the cattle. We tend to understand their dynamics just by virtue of asking people and so being well connected with locals on the ground. We've put collars on a variety of different predator species and prey species. What we've seen from that data is what you might expect, in that there is a correspondence between the two. In particular, we've seen that with lions and African buffalo, which is one of lions' main prey species, such that the lions do tend to follow buffalo, at least in some areas where we have that data. One of the problems with this type of work is that it's just very expensive and very difficult to find animals, to deploy the collars, to keep them running over many years. And so the fact that we've managed to do that here, over almost 15 years, starting in 2007, it's really lent us insights that we wouldn't have had if we had, say, just done this work for 2 or 3 years, which I'd say is often more typical of a research project of this type. So I think it really emphasizes the importance to long-term research and to an organization like WWF being willing to invest in that over the long term. That information can really make fundamental differences in terms of how an area is managed. And so, I think it's extremely important that we continue to do that. When we started doing this research in 2007, KAZA actually didn't exist. We started the research for other purposes, but it just goes to show that if you keep research like this going, the science can actually inform your work in ways that you couldn't have anticipated when you started it. So I think it's a real great lesson, on the value of long-term research and of incorporating applied research into the type of work that WWF and other conservation organizations do.
Thank you. And I know I said that was the last question, but we got a really good question. And I don't think it'll take too long. So this question is from Pam. Can a chip be used instead of a collar?
Yeah, it's a good question. And, you know, this is sort of an area of technology that I think is really rapidly advancing. So as with other areas, these transmitters are becoming lighter, they're becoming more durable, they're lasting longer. And so I could see the day when yeah, that, you know, just like your pet dog or cat is microchipped, you know, that could be the case with these satellite transmitters. We're not there yet, but yeah, it wouldn't be surprising if we did get there. And you know, certainly more and more species are now coming into play in terms of being able to tag them from a satellite point of view. So it wouldn't surprise me at all if that happens in the not so distant future.
Well, thank you. Thank you all for your questions. And thank you, Robin. We really appreciated you taking the time and sharing your generous work with us. And thanks to everyone who carved out time in your schedules to join us today for this installment of the Insider Series. We're going to be following up with an email that includes a link to a recording of today's program, along with a survey about your experience. We want to make sure that we adjust and improve future events where we can, so please be honest. We also hope you'll share the recording with your family and friends. Finally, please mark your calendars for the next installment of the WWF Insider Series. On Thursday, October 22nd at 2 p.m. Eastern Time, we will hear from Meg Symington, Managing Director of WWF's Amazon program. And keep checking your email inbox or wwf.events.org for information on future installments of the Insider Series. Thank you all.
Your passion and generosity are helping build a more resilient future for nature and people. And while we are all staying home and staying safe, your commitment is still helping to make conservation progress happen all over the world. From the U.S. Northern Great Plains to the Arctic, from the Eastern Himalayas to the savannas of Africa, your commitment fuels work that safeguards local communities, iconic wildlife, and vast land and waterscapes. Together, we're developing innovative solutions to ensure the health of our planet.
Your support is helping to take us to a whole new level in our work.
Support that people like you have provided has achieved so much.
Thank you for your generous support.
Thank you so much for your support.
Thank you for your support.
We can't do the work that we do alone.
We're doing all of this great work at WWF. We have all of these amazing supporters out there. And it is really nice to be able to connect with the people that enable us to do this work.